When we started this section, I mentioned that the reason we're covering circles at this later point in the semester is because it really didn't make sense to me to look at circles and then suddenly switch our focus to looking at functions for the rest of chapter 1. Made a lot more sense to look at circles when we were about to start our trig, where we'll be working a lot with circles, and in particular with the unit circle. And remember, the unit circle has as its equation just x squared plus y squared is equal to 1. And of course, like all circles, that is not the graph of a function because it fails the vertical line test. But that doesn't mean we need to abandon our study of functions when we start working with circles, because there are actually two related functions that I can associate with this unit circle. Okay. Let's just think back to before we sort of knew that that was a circle, so it failed the vertical line test, and before we knew that if there were even powers of y in our equations, it was not going to be a function. If we were given an equation and we wanted to see if we could get a function, we would see if we could solve for y. And if we got a unique formula for y, then we knew that we had a function. So if I were to try to solve for y squared is equal to 1 minus x squared. In order to get to just y, I would try taking the square root of both sides. But the square root of y squared isn't just y. That's the absolute value of y would be the square root of 1 minus x squared, which would mean I have two options. Y could be plus or minus the square root of 1 minus x squared. So this equation did not describe a function. It was actually two functions. And if I take a look at y equals the positive square root of 1 minus x squared, that's just going to be the top half of the unit circle, including the points on the x-axis and everything above it. Because if y is equal to the principal square root of something, that's saying that it isn't negative. Now, the top half of the circle passes the vertical line test. If I were to take my other option, y equals negative the square root of 1 minus x squared, that's also a function. That would be the bottom half of the circle. And it would also include these 2 points on the x-axis. So those 2 points would actually be on the graphs of both functions. But I can view this circle as being the graph of two functions, the function that gives me the top half and the function that gives me the bottom half. So I can work with functions when I'm working with circles. I just have to work with half a circle at a time. Now, having seen that, I might now recognize that certain functions are going to have as their graph half of a circle. Let's suppose I had y is equal to the square root of x plus 2, of 4 minus x plus 2 squared. Okay. Well, that looks somewhat similar to this one, because it's the positive square root. Okay. I've got my y value is a square root of a number minus an expression involving some x's squared. What I'm going to do to try to figure out what that graph looks like is I'm going to square both sides. So I'm going to get y squared is equal to, if I square this right-hand side, I'm just going to eliminate the radical. So it's 4 minus x plus 2 squared. Now, I need to record something else though, because this equation is not equivalent to this equation. In this equation, I can see that y cannot be a negative number because it's defined to be the principal square root of something. Here, y could be negative. If I'm trying to get to an equivalent equation, I'm going to need to record my restriction that y is bigger than or equal to 0. That says we're just looking at the top part of this graph. If I now add over the x plus 2 squared to the other side, this is going to become x plus 2 squared plus y squared equals 4, y bigger than or equal to 0. And now I can recognize this would be the equation of a circle. This restriction on y tells me I'm looking at the top half. Okay. And it's going to have as its center, looks like it would be negative 2, 0, because we're not adding or subtracting anything to the y value. My radius, that's my radius squared, so my radius would equal 2. And so I can actually draw that. Here's negative 2, 0. I'm going to temporarily put a point there, although I'll eventually erase that because that's not actually going to be a point on the circle. I want just the top half, and the radius is 2. So the point furthest to the left would be over here at negative 4, 0. Looks like it's going to go through the origin. That's the point furthest to the right. And the point highest up would be 2 units above. So we're getting just this half circle. Excellent. And I erased the center because it wasn't actually a point on the graph of this function. Very nice. Now, if we hadn't just done this work over here with the unit circle, you might have said, I have no idea what that looks like. So this is a really useful technique. When you see equations like this that involve square roots, sometimes squaring both sides and recording any restrictions that you had in the original equation allows you to manipulate the equation to make it look a lot more familiar so you can recognize that you're getting just half of a circle.